We are gonna do the first hover test for the new model. This is the Stingray VTOL, and I'm super excited to see how it flies. Starting to rain, so this is it.
As you've probably seen in the last episode, we 3D printed this drone using ASA-CF. And honestly, for me it was about time that I pulled the trigger and purchased a Bamboo P1S 3D printer. Of course, I instantly upgraded to the hardened nozzle and hardened extruder gears in order to be able to print with CF, and I also purchased a filament dryer. Once the drone was fully printed, we gave it a very simple coat of primer and clear coat, which is absolutely optional. Now let's do a speed run of the build, because you've already seen how most of that works.
We have new shipments, one of the first ones, for the new drone. This will be the structure of the drone, all those beautiful carbon fiber tubes.
The build process for the Super Stingray VTOL is exactly the same as the Stallion one. We essentially glue all the pieces together using simple CA glue. And meanwhile we admire the absolutely stunning finish of the ASA-CF. Keep in mind that ASA is prone to warping, so I would advise you to add more brims in the print settings and use adhesive on the build plate. A subtle difference between ASA-CF and lightweight PLA is that it takes a little bit more heat in order to apply the inserts. And as with any 3D printed part, you may need to do a little bit of post-processing. In my case, I had some issues with overhangs, but that's to be expected.
And now that we have the nose installed, there is one more thing I've been eager to install ever since I got it. And this is the rear motor. This is the Emax Pro Series, and it's so much bigger than the other one. It's just, I don't know, it looks awesome in person.
Next up, I did some work on the electronics before moving on to the wings.
I decided to reuse the flight controller from the previous drone, and this is its power distribution board. And currently we already have two cables for the 4-in-1 ESC, basically for this thing, for the 4 vertical motors. And I also need to solder this one, which is the ESC for the rear motor. It's gonna be a little tight, but this is what we have to achieve. Right, so I'm in a bit of a pickle, but I'm gonna try and explain what the issue is. You can see inside of here, there is a hole in the carbon tube through which these wires come out. And the issue is that I already glued this part, so it would be very hard, close to impossible, to route the new cables for the other motor on the other end. Because I already did this one, but now we have to do the other one. So I already soldered the extensions, and now I made a solid tip. I'm gonna wire them in, and then they're just gonna bump in the other cables. So what worked for the previous one was I used one of these packing metal thingies, and I just made a hook like this, and as soon as the cable got to this point, I started pulling up. That worked for one side. We'll see whether it works for the other. Okay, so So now that we wired these, there are two more things that we need to do. First of all is we need to secure those motor mounts from the both sides. I actually modified the designs to accommodate for the bigger motors. These are the Emax Eco 2 1300 kV 2807. The parts of the wires that are going to connect to the ESC, I actually added these plugs to make it easier to change ESCs if I ever need to, because in the past I needed to, so that I can just plug them in the ESC and unplug. It's super simple. It takes a little bit more time, but it should save time in the long run. I may have melted them a little, or at least some of them, yeah. But other than that, this is how they plug in, so they are interchangeable from now on. And I can then code the direction of the motors using the Arduino board. Right, so I fixed the soldering iron by isolating the wires and hot gluing the iron in place since the plastic broke. And now we can put the top side. And then, once we make the adjustments, it should not be able to rotate on the axis of the carbon tube. So I had the brilliant idea of using hot glue to assemble the soldering iron again, which is one of my best inventions yet. Yeah, so obviously hot glue is not gonna fix a broken soldering iron. This certainly took a while, but now these are ready. This is the VTOL mechanism that attaches to the wings, and now all of those are aligned. I just eyeballed them, because you need to align this, this, and this. The next order of business is assembling the wings.
Fortunately for both you and me, assembling the wings is just as easy as assembling the fuselage. We essentially use the carbon tubes as guides and we just add CA glue in order to glue the parts together, and that's pretty much it. So yeah, sit back, relax, and enjoy the music.
So next up we need to attach the ailerons to the wings. So it should be something like this. And for that we use polyester hinges like these. They are super strong. Or I also have this sheet of polyester that I can cut with scissors.
To be completely honest, this process takes forever and it's rather annoying, so I would love if these designs were to accommodate a simple carbon tube running through the aileron. I'm sure that will add a little bit of weight, but I mean, it will be such a quality of life improvement. Anyways, enough ranting.
And now that we have the wings with the ailerons, we need to put the servos in. Sort of like this. And then I need to 3D print control horns. That will be the link between the servo and the aileron.
As always, the link to the custom parts can be found in the video description. As a final step, we want to make sure that the servo is at its middle position and that it's locked in place. And then we can just test the servo movements just to make sure that everything is set up correctly.
So, big news, the airframe is fully assembled. And what's left for me to do is the electronics inside, for which I would need to design some mounts. And I also need to figure out the center of gravity for this aircraft because we don't want to crash it the first time around. We've already done that.
Once that was sorted out, I proceeded to design a mount for the flight controller, ESC and GPS, 3 in 1, and then proceeded to 3D print it, of course. While it was printing, I installed the DJI O3 Air Unit's camera on the nose of the aircraft, and then literally drilled some holes in order to install an airspeed sensor. This is one of the biggest mistakes I've done in my previous two builds because airspeed sensors are absolutely essential for fixed-wing aircraft, because there is always a difference between the ground speed and the airspeed due to winds, and of course you always need to have enough airspeed in order to not stall. And of course the airspeed sensor should receive a clear flow of air, ideally positioning it up front. This is a Matek airspeed sensor that consists of a pitot tube that splits into two in order to measure the air differences in pressure. And then there are tubes that connect to the actual sensor, and then the sensor connects to the flight controller. And it provides real-time data on the airspeed of the aircraft, because the GPS only provides the ground speed. I then proceeded to try out the first version of the mount for the flight controller, ESC and GPS, but of course we never get it right the first time. I then proceeded with another design, but of course we don't get it right the second time either.
So this part works very well. I would have to redesign this because the GPS doesn't fit.
And as they say, third time's the charm.
Right, so here's the updated version of the mount I designed. So this thing straps onto the carbon tube, and there is this TPU rubbery thing that goes underneath to take away some of the vibrations. Right, let me try to explain how everything works. So we have 4 motors on each side, which are only responsible for vertical takeoff and landing. And then we have a 5th motor on the back that is responsible for forward flight. All of that happens in the flight controller. So this is essentially sending signals and processing all the data from the sensors. This is the GPS. It is connected to the flight controller.
One important disclaimer is that the GPS contains a compass, and that should be placed as far away from high voltage cables as possible, so this is really not a good place to install a GPS.
Underneath here we have an 4-in-1 ESC, which is responsible for powering each of the 4 quad motors. It is also connected with a signal cable to the pins on the flight controller. Here we have an additional ESC, which is only responsible for the rear motor. So we have 2 ESCs. In addition, we have a 24-volt fan that is actively cooling all of those components here, especially the ESCs, which is important because the airframe is closed. And here we also have connected 2 of the servos, which are responsible for the 2 ailerons on this aircraft. In addition, this is the part that connects via USB to a computer. This is the airspeed sensor. So this is the tube. This is how it measures airspeed and air pressure. The tube connects to here, and then this connects to the flight controller. Here in the front we have the VTX, which is the O3 air unit. This is the antenna. And then in front of it we have active cooling that is essentially powered from one of the pins as well, so it works all the time. And we have the actual VTX connected here. So that's pretty much everything we need. Everything else is programming, configuration, and plugging in the battery. Status update on the battery. I honestly don't think we can save it. So initially it shows that 2 of the cells are dead. As I told you, I tried to charge it to 60% once a month. I don't know what happened, but it doesn't want to charge. So it's showing a cell count error. And if I try to charge it with either of the 2 other mods without the balance chargers, the balance leads, it just shows battery voltage error, and that's it. And when I measure the voltage, we can see that it is 16.56, which is not good. It took me about 4 hours to pick a new battery, and this is what I ended up picking. Initially, I wanted to go with the new semi-solid state batteries, but they have a very low C rating, and I don't believe it will be sufficient for a VTOL aircraft. It would be mostly for fixed-wing aircraft without VTOL capabilities. So I'm taking a safer bet with this one. It has a higher C rating, although the watt hours per kilogram are not as impressive, but they are still like 30% better than the old one. And we would have nearly twice the capacity for just 400 grams more. Alright, so here's something very cool. Now, I just got my new battery pack, and this time I decided to buy one of these LiPo alarms. If some of the cells drop below voltage, this thing starts beeping, and that's how you know that your pack is going away. Yeah, that's not gonna be easy. Hey.
And this, my friends, is the sound of failure, but we'll sort it out.
I will of course need to strap the battery, but I can see that the airspeed sensor is working. The GPS is connected, the ESC was beeping, active cooling is working. Essentially everything seems to work. Let's see if, yep, the DJI All-3 air unit is also connected. So technically we should be good to go after we do all of the configurations. And once I figure out how to strap this monster of a battery, because we would need to do the accelerometer calibrations, which means, jiggling the plane around. So yeah, that's gonna be fun. Right, so it's a beautiful day, and I managed to find a place where we can actually do the first hover test. So I've got the drone here with me, and we're at a pretty secluded park. We're not going to do forward flight, so we're not putting anyone in danger. What I need to do is to double check all the pre-flight tests, make sure we're ready to fly, and then do the hover test. Okay.
At this point, these two very awesome dudes started asking questions about the drone, so I went ahead and explained how everything works. I always find it fascinating how people find it fascinating. But yeah, these guys actually subscribed to the channel, which is something that you guys should do too.
Center of gravity is good. Okay. All right, we have RC control. And we have a pinging satellite, so that means we're good. So I'm gonna plug it into the computer and see what's left to do on the pre-flight checks. And this time, since we're using an advanced filament, this is not gonna melt in the sun.
Spoiler alert, it may not melt, but it will most certainly crack.
All right, so we're seeing an error with the mag field, and that probably means that we need to calibrate the compass once again, or it's because maybe it's on the table, although it's aluminum, so it shouldn't be an issue. Or we can try plugging it in on the ground, actually. All right, so I actually disabled the compass because I'm pretty sure we don't need it for hover mode. I'm gonna troubleshoot why it didn't work after that. So I think we're ready to do the first hover test. There are dogs around, so I'm gonna wait a little. But other than that, we should be good. I have GPS lock. Okay, so we have an arm and disarm channel. Let's see. All right. We are arming, but one of the rotors isn't spinning for some reason. It was spinning last time I tried it, so I'm not really sure what's going on. Let me just try it. It should be here. Right. All right. Okay. Closing it up, because otherwise dust gets everywhere. Admittedly, this is not the best takeoff location, but we're gonna do that anyways. Okay, I'm gonna abort because there are dogs around. It's starting to rain, so this is it. Well, that was not ideal. And it started to rain, so I guess that's the end of today. Okay, so here's what happened. Essentially the drone took off and this started spinning, and that's why it lost control. So I need to find a way to secure this a lot more. We do have some damage on the bottom, but it's nothing we can't duct tape over. So yeah, it's a bit of unfortunate, but otherwise it took off, so I guess it's gonna work. And now let's get away from the rain. We could have done another test, but I really want to make sure that those things are secured. I added a little bit of silicone, but I guess that wasn't enough. Most of them are secure, but I guess this one wasn't, which is an oversight on my part. But other than that, the drone had no problem taking off, so it's going to be fine.